Alright folks, hello and welcome to this video lesson on section 2.8. We're going to graph linear inequalities in two variables. Please copy these notes into your notebook and make sure to put a star or question mark about anything that you have questions on for class. So first we're going to look at two forms of equations, just like we did for graphing lines. When we're graphing inequalities, we want an equation form we're familiar with. So the standard form is going to look just like the standard form of a line equation or linear equation, except instead of a equal sign, we're going to have an inequality symbol, such as greater than C. You could also have greater than or equal to. You can also have less than or equal to, etc., etc. You can change it up, but this here must be an inequality symbol in order to have a linear inequality in two variables. So I'm just going to put inequality symbol, and any of the four will do. Greater than, less than, greater than or equal to, or less than or equal to. Similarly, we have slope-intercept form, which will be y, and then inequality symbol again. This time I'll do less than mx plus b. This doesn't have to be less than, it doesn't have to be greater than, it just has to be one of the inequality symbols. And there are your two forms of equations. So, you can see how this builds on linear equation knowledge already, but let's look at the graph. The graph is going to be a little bit different than just a line. It's the set of all points x comma y that make the inequality true. It's indicated by a shaded region. So for example, we're going to have some type of line. I'll just make a straight line here with the red line. And if we were graphing an equation, we'd be done. But now that we're doing an inequality, we're going to have a less than or equal to, something of that nature. And there's going to be more solutions than just the points on this line. So previously, only the points that are on this line, I'm missing the line slightly, but you get the picture. Only the points on that line are a solution to the equation. But when you have an inequality, you might find, for example, that this entire region that I'm shading below the line is a solution to that inequality, not just the points on the line, but that region below. Sometimes this is called the half plane. Corresponding half plane because it cuts the plane in half, quote unquote. I mean, it's an infinite plane, so what does it really mean to cut it in half? It's a little bit fuzzy there, but it's called the half plane because it's split according to where it's a solution, which will shade, and not a solution, which will not be shaded. Another thing to take note of is whether the line is going to be solid, as it is there, or dashed, as I'll draw in a second. For example, you might have a line like this when we're doing inequalities. Ooh, that's a messy line. Let's fix that a little bit. Okay, it's a little bit better of a dashed line, and that is going to indicate whether or not the line is included. So we have dashed, we have solid, and those are going to tell you something. When it's dashed, it means that the line is not included. That's for the strictly less than or the strictly greater than symbols. If it's solid, it means the line is included in our solution set, and that'll be for the greater than or equal to or the less than or equal to symbols. So just get that under your belt for when you're graphing these lines. Next up, we'll look at the two-step graphing procedure, and here it is. First, you're going to graph the associated equation with a dashed or solid line, and then second, you're going to shade the solution region. Now, when it comes to shading the solution region, there's two main ways of doing it. The first is to use the less than or greater than symbols if it's in slope-intercept form. If it's in slope-intercept form, all you need is to know whether it's this symbol greater than, could be greater than or equal to, or less than or equal to. If it's in slope-intercept form and you have one of those symbols that you can recognize, you can know where to shade right away. So that's actually the easiest. You can shade right away if you know that form. However, if it's not in slope-intercept form, what you're going to do is use a test point. And the test point, it will work for if it's in standard form, slope-intercept form, or really just any form at all. Technically, you could have a point-slope inequality, or a point-slope linear inequality. I wouldn't recommend it, but you could have it. So the test point that's typically used is 0, 0. You can use variations of that, 1, 0, 0, 1. And the point is to choose numbers that are easy to evaluate. And when you test, you're going to plug that ordered pair into your inequality, see if it's true, and if it's true, you know that the region containing that test point must be shaded. If it's not true, then you're going to shade the other half plane. Okay, so that test point is going to determine whether you should shade or should not shade, and that's going to depend on plugging in an x and y and checking if it's true. Remember, if it's in slope-intercept form, you don't need to do this. You could still use a test point in slope-intercept form, but you don't have to. In standard form, you definitely will need to do this procedure of a test point or convert it to slope-intercept form first. So now let's look at two examples using that two-step procedure. The first is an equation in standard form. And to graph an equation in standard form, I like to use the x and y intercepts. You're welcome to change it if you'd like, or try this by a different procedure. But I'm going to follow the first step, and I'm going to try to graph the associated equation. And what that means is just considering this as an equation, 5x minus 2y equals -4. What would that look like? What would that line look like? That's the line I'm going to graph, and I'm going to make it solid or dashed based on this. It is inclusive. It's less than or equal to, meaning it's including the line itself. So it's going to be a solid line. So that's what I'm going to sketch, and then the second step we'll look at how to shade. So my x-intercept, I set y equal to 0. That means 5x equals -4, x equals -4/5. For my y-intercept, I set x equal to 0, and then I have -2y equals -4. Remember, I'm working with an equal sign because I'm looking at the associated equation. I will consider the inequality when it comes to shading. Divide by -2, and we have y equals 2. All right, so that's enough info for me to sketch this. Remember, all I require is 2 points when you're sketching a line. You don't have to be fancy in making it perfect on graph paper. You just got to show me 2 points. So x is -4/5, 0. So let's get a little scale there. 3, 1, 2, 3. That's +3. And let's go 1, 2, 3, +3, 1, 2, 3, -3. But again, you don't really even need the scale. If you just want to do the points, that's fine too. But let's try to get as accurate as possible here. Oops, I missed. Let's see if I can fix that. Okay, so that's a little messy there, but I have my 4/5, 0. I'm just trying to cover up that first black spot I made. And then I plotted my 0, 2. If it falls on an exact point like 0, 2, I don't need the ordered pair listed if you have a scale. But if you want to label it 2 for consistency, that would be fine. So, I mean, this would be 0, 2 if you want to write that. And then that's our line. I made it a solid line because of our inequality. And now I just have to figure out which side to shade. Since it's in standard form, I'm going to use the test point. And my test point is going to be the origin, 0, 0, which notice it falls on this side of the line here. The right side here falls on that part. And so let's plug that in and see if we can figure out whether to shade there or not. So plugging in 0 for x and y, well, 5 times 0, that just gives us 0. -2 times 0 gives us 0. We end up with the inequality 0 is less than or equal to -4. And then we have to ask ourselves, is that true? And think about it for a second. True, 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 false, 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 and that is false. Okay, 0 is not less than -4, so we must not shade the side containing the origin. The origin is not a solution. You don't have to write that. I'm just doing it for emphasis. That's not a solution. Therefore, the other half must be a solution. So I'm going to shade the opposite region, or this part here. Now you can actually shade it in with a pencil, or you can just make straight lines like this. That's a convention that's often used to indicate shading. And that's how you would graph that linear inequality. Looking at example 2, I notice it's not in either form, so I'm just going to get it into slope-intercept form by adding 1 to both sides. That'll be 3/4 x plus 1. It's a strictly greater than symbol, so looking at the associated equation first, I am not going to make a solid line, but a dashed line. So remember, step 1, look at the associated equation. Graph a solid or dashed line. Let's do that. Here's our x, here's our y, and I'm going to do a dashed line with a y-intercept of 1 right there, and it's going to have a slope of 3/4, which means, you know what, I'm just going to stay with the integers here. I'm going to go over, or I'm going to go up 3, rise over run. So that's a rise of 3 and a run of 4, and that's going to put me at 1, 2, 3. Oops, I forgot the 4. 4, 5. So that'll be rise 3 will put me up here at 4, right there. And then we'll go over to 4 there, and this will be the point 4, 4. All right, we took 0, 1, and we rose 3 and ran 4. Rise over run for the slope. If you want to plot, just go up 3/4 and over 1. That's also acceptable. And this will be a dashed line. Next up, we have to figure out which half plane to shade. Since it's in slope-intercept form, I'm just going to think about the symbol. This is a greater than symbol, which means that we want to shade where y is greater. I'm sorry, I'm looking at the wrong one. This symbol here is what you want to look at, our equation where y is isolated, but it's greater than, and that means the solutions are going to be where the y value is greater than this entire expression. And where the y value is going to be greater than that expression, if that expression is graphed by this line, well, the y values are going to be greater. Think about where y is greater. The y-axis goes up this way, and it's greater when it's above the line. So a greater than symbol, when you're in slope-intercept form, means you're going to shade above, because that's where y is greater. If it was less than, well, where is y less? You know the y-axis goes like this, and it gets less as you go down. It gets like more negative region. Okay, so just by judging the symbol, y is greater than shows me that I need to shade above. Remember, that only works in slope-intercept form. If it wasn't, I'd need a test point. And that's how to graph two inequalities in two variables. So a summary of section 2.8. In this lesson, we examined linear inequalities in two variables. We talked about what their graph looks like and how it shows all of the solutions by shading. Next, we looked at a two-step graphing procedure. Namely, you graph the associated equation and then you shade the correct half plane. And then last, we looked at two examples on how to put that two-step graphing procedure into practice. Remember to bring in any questions you have about this lesson, and thanks for watching.